TCP is an example of a protocol that is connection-oriented, unlike UDP. This means that a connection needs to be established before data is sent. So how is it established? Via a mechanism called handshake, which ensures both sides agree to the dialogue. Let's see what really is enough to establish a connection between the two sides. Let's start with the simplest example, a two-way handshake, where both sides, in our case Alice and Bob, want to connect. Alice says to Bob, "Let's chat," and Bob agrees. At first glance, this looks like a suitable method of establishing a connection between them, which will provide the option to continue the conversation. But we shouldn't forget that the reliability service which assures the packets arrive in the right order isn't yet activated. We're just trying to establish the connection between the two. The question is whether a two-way handshake really is enough. The next example we look at shows that the two-way handshake is not a method that provides a response in all cases. Let's now look at more cases where the two-way handshake doesn't work. Alice wants to connect by sending a REC-CON. Bob answers Alice with an ACC-CON. But before the acknowledgement gets to Alice, she gives up and sends a new request connection. And at the same time, the client simply terminates. The server forgets the connection they were trying to establish, and only then does Alice's second request connection try get to Bob. What do we do as a result? We have half a connection open from Alice to Bob. This is the problem that can result when we use the two-way handshake. Let's see how we can fix the two-way handshake to cover all the issues. Let's look deeper at the acknowledgement going from Bob to Alice. What is the actual meaning of this message? It can include two things. It can include the acknowledgement of connecting from Alice, but inside, the same message can include the connection request from the other side, from Bob to Alice. Remember, eventually we need to create a full duplex connection. This is exactly what TCP does. The first message is a synchronized request called SYN. How is it implemented? By lighting up a SYN flag. And the request is sent together with a serial number X, and Bob sends a message called SYN-ACK, which includes a connection request from Bob to Alice, but also an acknowledgement to Alice's previous request. Meaning that the two-way handshake is precisely the SYN and SYN-ACK in TCP. But how will Bob know that this SYN-ACK arrived? There needs to be one more message from Alice to Bob, which in TCP is called ACK. This is a three-way handshake implemented in TCP. It covers all problematic scenarios. Let's see how a connection is closed in TCP. As you may recall, TCP is full duplex, meaning there are two directions transmitting data between Alice and Bob at the same time. If we want to close one direction, the other direction can still send. Meaning that to close a TCP connection, we have to close off both directions. If Alice now wants to close her direction, she has to send a message with a lit-up FIN flag inside the TCP header. And as a response to the message, Bob simply has to acknowledge. Similarly, in the other direction, if Bob wants to close his end, he will send a FIN message to Alice, and Alice will respond with an acknowledgement. The FIN and ACK can be combined within the same message to decrease the number of messages exchanged. Let's look at how connections are closed. Alice is on the left. Bob is on the right. She tries to send her direction, and from then, she can no longer send data to Bob. And Bob acknowledges Alice. By the way, Bob can still send a word to Alice, and when Bob tries to send the lit-up FIN bit in his message, as if he's trying to close the connection from his end, and an ACK is sent from Alice's side, and from that moment, you can see both directions are closed, and the entire connection is closed.